All right, in this section, we're going to talk about the ellipse. So the ellipse has a lot of similarities to a circle, but in a circle, the horizontal distance across and the vertical distance across is all the same diameter. In an ellipse, you have a major axis and a minor axis. So one direction is going to be longer. Now, here's the very formal definition of an ellipse. And as we read through this definition, I want you to think about this diagram over here with the hand, okay, figure 9.2. Think about it this way. If you were to take a string, something that's not stretchy, if you take a string and attach it to two nails, and then you put your pencil and let the string guide you as you pull away from those nails, you're going to end up drawing what's called an ellipse. Okay, and so an ellipse is the set of all points P in a plane, the sum of whose distances from two fixed points, F1 and F2, is constant. These fixed points, which would be the pins on the diagram, are called the foci, or foci, depending on who you ask, and that is the plural of focus. We don't say focuses, it's foci or foci. And then the midpoint of the segment connecting the foci is the center of the ellipse. So what we always are going to have is this distance here, A, and this distance here, B. This would be F1 and F2. If you think about if you went straight up, because you have a little bit of room between the total length of this string is more than the distance from F1 to F2. So you would start by pulling it straight up here. And then again, as you move your way around, the string is always going to be pulled like a triangle, no matter where you have the pencil. And it's going to do that all the way around. The path that you would trace is going to be an ellipse. Okay, now an ellipse can be oriented either vertically or horizontally. So the one here on the left is what we would call a horizontal elongation of an ellipse, whereas the major axis, which is the longer one, is horizontal and the minor axis is vertical, versus the opposite of that, which is going to be a vertical ellipse. Okay, now here's the standard form of the equations of an ellipse with a center at 0, 0. Now we're going to talk about moving it, but just to start, we're going to start with the center at 0, 0, okay? The major and minor axes will have lengths of 2a and 2b. A and B are similar to like the radius in a circle. So you have to double it to get the diameter. Same thing here. We figure out what A is, we figure out what B is, and then we double it. That tells you the length across. It's sort of like a different radius, even though that's not what we call it here, okay? Here's what's important. A and B are always positive, and for this conic section, A squared has to always be bigger than B squared, okay? That matters because since order doesn't matter with addition, we have to know whether the bigger number is under the X or whether the bigger number is under the Y. When the bigger number is under the X, that's when you get a horizontal axis, a horizontal ellipse. When the bigger number is under the Y's, that's when you know that you have a vertical ellipse, okay? Now, the way that we find the location of the foci, they're going to be, remember that's where those two pins would be, or the nails. The foci are always on the major axis, and they're going to be C units from the center. So we always need to find an A, a B, and then we need to find the C's. The way that we figure out the value of C is that C squared is equal to A squared minus B squared. It's similar to the Pythagorean theorem, but you have a minus instead. Okay, so these are the formulas that we'll be working with. So let's go ahead then and talk about graphing a couple of these. So we want to graph and locate the foci for each of these equations. The first thing we have to decide is it going to be horizontal or vertical? And in this case, I know that it is horizontal because 9 is bigger and 9 is under the X. So that tells us that this is A squared and this is B squared. That tells us then that A is equal to 3 because 3 squared is 9, and B must be equal to 2. This is always going to be equal to 1 when it's in standard form. So that's always where we need to start, is with that equal to 1. Now, we need to figure out what C is. C squared, oops, my pen died. C squared is equal to A squared minus B squared. So that means that C is equal to 5. We're always looking, the square root of 5. We're always looking for positive values here because it's measuring a distance on the graph. So since we have our center at 0, 0, okay, the center is going to be at 0, 0, then we have what are called the vertices and the co-vertices, okay? The vertices come from the major axis. So those are going to be our A's. We're either going to go, since it's horizontal, we're going to go to the right 3 and to the left 3. So we have negative 3, 0 and positive 3, 0. Those are our vertices. The co-vertices are what come from the minor axis. So that's the B value, which is along the Y direction. So we go up 2 and down 2. It's just like a circle, except it's not the same distance always everywhere. So that is going to be the points 0, 2 and 0, negative 2. Then we need to locate the foci, which we're also going to graph. The square root of 5 is, let's see here. Whoops, I'm doing the wrong thing. Square root of 5 is about 2.2, okay? So that's the approximate value of the square root of 5. That helps us know where to graph it. The foci always go along the longer axis, the major axis. So that would be right here, 2.2, and right here. Now the graph does not go through the foci. The foci are part of the definition. And so the foci are going to be at negative square root of 5, 0, positive square root of 5, 0. And so here is our ellipse. It's an oval shape. Okay. Now number 2 looks a little bit different to start, but the key here is because, as I mentioned at the beginning, it has to be equal to 1. The first thing that we have to do is divide everything by 400. When we do that, we can simplify these fractions. Let's see, 25 goes into 400 16 times. So this comes out to x squared over 16. And then 16 goes into 400 25 times, and that's equal to 1. So now you can see on this one, the bigger number is underneath the y squared. So this one is going to be a vertical ellipse. So go ahead and take a moment to pause your video and see if you can finish this one on your own. I'll be back in 2 seconds. All right, this one is a vertical ellipse. A is equal to 5, B is equal to 4, C comes out to be the square root of 11, which is about 3.3. So that's how we can come up with our graph. We see it's longer vertically than it is horizontally, so that's correct. And then you can determine all of those values. It didn't ask for them here, but a lot of times it will by using that information. Okay, let's look then at how we could work a little bit backwards. So it says, find the standard form of the equation of an ellipse with foci at negative 1, 0 and 1, 0, and vertices at negative 2, 0 and positive 2, 0. Okay, so first thing is look at what we've got. We have y values of 0 for the foci and the vertices. That means that they're along the x-axis, which means this is going to be a horizontal ellipse, okay, because of where those ordered pairs are. So that means that when we set this up, x squared, y squared equals 1, I need the number underneath the x squared to be the bigger one, okay? Now, I can tell by these numbers here that A is equal to 2 because we're centered at the origin. They're 2 units away. So that means that A squared is going to be 4. Now the foci give us the value of C. C is equal to 1. Now they didn't give us the B values, but we can find them because again, we know that C squared is equal to A squared minus B squared. So we get 1 is equal to 4 minus b squared. So if I add b squared and then subtract 1, we get that b is the square root of 3. Really all we needed here was b squared because that's what goes on the bottom. And so this would be the equation of that ellipse. Let's talk about if the center moves. Really, the only thing that changes is the HK, just the way that it does on a circle, okay? So H and K will give us the new center, but all the other rules are the same. Now, to find our ordered pairs, this is where it gets a little bit trickier. If our major axis is horizontal, meaning the ellipse is horizontal and a squared is underneath the x's, then to find the vertices, then we are moving in the x direction. So you're going to add the distance of A, you're going to add it to the h. And then to get to the opposite side, you're going to subtract it from the h because it's the horizontal distance. If you wanted to do the co-vertices, you would add it and subtract it from the k, all right? If your ellipse is vertical, then to find the vertices, you're going to add and subtract from k because that is where your a value is going to go. You're going to go a in the positive direction, a in the negative direction is how that will work. So that really doesn't change our process very much at all. The way that you find the foci is very, very similar. So we want to graph this equation here. The first thing that we need to decide is where's our center. So the center in this case is going to be at positive 1, negative 2. Switch the signs just like with circles. I noticed that the bigger number is under the y, so that tells us that this is a vertical ellipse. And so to find our vertices, the vertices are going to be at 1, and then negative 2 plus or minus whatever the value of a is. That's how we're going to get there from the center. Let's look at this graphically first, okay? We can see from here that we have a is equal to 3 and therefore b is equal to 2 once we know that this is the a squared, okay? So if we put our center, which is at 1, negative 2, nope, that's not that point. 1, negative 2 is down here, okay? Then we want, from there, we want to go up a and down a. So that's up 3 and down 3. Look at where we ended up with. We ended up at the point 1, 1. That's because that's going to be negative 2 plus 3. So 1, 1 is our first vertex. And then we need to do negative 2 minus 3, which should take us to 1, negative 5. And if you look at the graph, that's exactly where we ended up. Now the A's are vertical. The B's are going to be horizontal. So we're going to go 2, in either direction here. So here's our ellipse. Now we just need to figure out where the foci are. And we've already seen c squared equals a squared minus b squared. We've done this one in a previous problem. C is going to be equal to the square root of 5, which is about 2.2. So that's like here, and here. There's our foci. And so to figure out the foci, we do the exact same thing. The foci, or foci, I always say it both ways, are going to be just like the vertices, but we're going to add and subtract c. So we'll be at 1, negative 2 plus the square root of 5, and the other one will be at 1, negative 2 minus the square root of 5. Remember, we always work with exact values unless it tells us not to, so that's why I'm using the square root of 5 instead of 2.2. All right, so pause your video and turn the page and try number 5, please. I'll come back with the work in 2 seconds. Okay, here's what you get. Pause the video so that you can read through that and make sure that you are in line with that. And let's go ahead and move on to number 6. Okay, number 6 and 7, and this is the end. Number 6 and 7 are just like with circles, how we have to do some completing the square. But this one is a little bit trickier because notice that the coefficients of x and y are not 1. So this does make our process a little bit harder because we have to have it in the form of x squared plus bx. So first let's do some regrouping. I'm going to put the 9x squared minus 36x, and then I'm going to have the 25y squared plus 50y, and then I'm going to add the 164 over. Now, each of these has a common factor. It doesn't even matter if it's a common factor. If you end up with a fraction, then that's what you're going to have to do, because we have to divide out the coefficient of the squared because we have to get it to be 1. So this is where I'm going to put my blanks in. So I have 9 times x squared minus 4x plus blank. That's where we're going to complete the square. Plus 25 times y squared plus 2y plus blank. Here's where this gets tricky though. So this will equal 164 plus. It's not just the 2 blanks, because this blank is going to be whatever 9 times that. That's really what I'm adding. I'm not adding it once. I'm adding it 9 times on that side. I'm adding the other one 25 times. So we have to include those coefficients. So it's going to be 9 times blank plus 25 times blank. Okay, that's the part that's different here. Otherwise, from here on out, exactly the same. Half of b squared, half of b squared, add it on both sides. So what do we get here? We get 9 times x minus 2 squared plus 25 times y plus 1 squared equals, over here, let's see, we get 164 plus 36 plus 25. So that is 225. Now we're almost there, but remember that to get this in standard form, we have to have this equal to 1. So now we divide everything by 225 and we simplify these fractions. So 225 divided by 9 is 25. So this comes out to be x minus 2 squared over 25 plus this one simplifies to y plus 1 squared over 9 equals 1. Okay, from there, we can gather all of our information. So pause this now and see if you can graph that yourself. All right, go ahead and pause the video before I move this so that you can read through that and check your graph. And then once you have done that, I'd like you to go ahead and try number 7, see if you can convert that to standard form using completing the square. You don't need to go through the graphing process. We've practiced that enough now, but I would like you to take the time to complete the square. I'll come back with that work in just a couple of seconds. All right, here's what you should get. So notice you only had a GCF on one of them. The y squared already was a 1, so we didn't have to worry about the coefficient there. And then, remember, you have to divide everything by 64 to get it equal to 1 at the end. And then once you have that, you can figure out everything else you need. The center is -2, +3. It's vertical because 64 is bigger, and that's underneath the y. That means A is 8 and B is 4. You can figure out C, and that's how you're going to get your foci. And that's what you need to know about an ellipse.